Welcome to Summarize Science. Imagine an AI that doesn't just learn from its mistakes, but actually writes software to handle future tasks more efficiently. This is the core of AgentFactory, a framework where AI agents evolve by building a library of reusable code. Most current agents forget their specific solutions once a task is finished, requiring them to start from scratch every time. The researchers notice that diverse daily tasks often share the same basic building blocks. Instead of relearning these steps every time, AgentFactory saves them as executable subagents. These subagents are pure Python scripts that any compatible system can run and understand. The process follows a three-phase lifecycle: install, self-evolve, and deploy. First, the meta-agent decomposes a complex problem into smaller parts and writes code to solve each specific one. If the solution works, it is saved in a shared subagent pool for future use. In the self-evolve phase, the AI identifies failures in its existing tools and autonomously fixes the code. This means the system gets smarter and more robust without needing any human intervention to debug the script. This creates a loop where the AI constantly improves its own internal tools based on real-world feedback. We can see this in action when a subagent improves its data parsing logic over several different attempts. It might start with a simple, fragile method, but eventually evolves into a robust, professional-grade solution. This allows the AI to handle edge cases and errors that it didn't even know existed at the start. One fascinating aspect is the portability of these skills across different AI environments. Because they are saved as standard code, a subagent created in AgentFactory can be exported to other popular platforms. This allows different AI systems to share skills they have learned independently, like transcribing audio or managing files. In testing, the system handled complex tasks like planning travel itineraries and booking meetings. By the second round of similar tasks, the AI used much less brain power because it could simply run its saved programs. This efficiency gain is a major step forward for making autonomous agents practical for everyday use. The results showed that the system progressively reduces the effort required for similar tasks over time. Stronger AI models were particularly good at recognizing opportunities to reuse their growing library of skills. This turns the AI into a sort of AgentFactory that produces specialized, high-quality tools for any situation. To wrap up, AgentFactory moves us away from static AI memories toward a permanent, evolving toolkit of software. It builds, refines, and shares its own capabilities automatically without human help. In the future, this could lead to a world where AI systems constantly trade and improve specialized code-based skills. While the researchers implemented safety checks for the generated code, the potential for autonomous improvement is vast. This framework highlights how AI is beginning to manage its own development cycle to become more helpful. Thanks for watching Summarize Science, and we'll see you in the next breakdown.